Today we'll see voltage source control for grid-tied PV system. In the last video, we see already the current side control. Current control for grid-tied system. Here this is the equivalent circuit what we have discussed in the last video. Small signal model we can say. And this is the inverter voltage. VSO is M VDC by 2. It is something like VA. Like this we have VA, VB, VC. So if you add up all these things, this is VA, this is VB, this is VC. So VAIA plus VBAB plus VCIC, all these are grid parameters collectively together as the total power delivered by the inverter, which is equivalent to DC side power. So PDC is equal to PAC, we can say, as the inverter is almost having the efficiency above 95%. So PAC is approximately taken as a PDC, so we can write like this. VGAPC is the grid voltage and PCC is the point of common coupling, and IGAPC represents the grid currents, and this is a single capacitor we split into two for measuring the inverter pole voltage, that is VA naught is equal to VA. DC link power is written as PDC equal to MA VDC by 2 into IGA, MB VDC by 2 IGB, MC VDC by 2 into IDC, and it can be written as VDC into IDC. IDC is equal to, you can write it as MA IGA. So here we are cancelling the VDC component on either sides. So we can write this in the matrix form like this, and M and I are the column vectors, you can say. MA BC is equal to MA MB MC. ABC to DQ transformation, the derivatives substitutes MABC is equal to C transpose MDQ. IABC is C transpose IDQ. We will see what is this C matrix, where the C into C transpose will give us the 3 by 2 times of AND matrix, or you can simply call it as 3 by 2. It is a 3 by 3 vector, 2 by 3 vector. The current transformation used is IDQ is equal to C times of IABC. C is equal to 2 by 3 times of this matrix. And IDIQ can be written like this, where IDQ is C times of IABC, but C matrix is this one. So from this we can transform the ABC currents into DQ currents, where this theta is available from the PLL, which is connected at the grid side. So we can do the inverse transformation also. IABC is equal to transformation of the C matrix, transform of C matrix, transpose of C matrix like this. Here we find there is no 2 by 3 term, unlike what we have seen in current control in the last video. The modulation index transformation exactly the same as the matrix for modulating signals, also the same matrix we are using for transforming DQ to ABC or ABC to DQ for the modulation parameter also. Now this IDC can be written as half times of M transpose AAPC. So IDC is half of C transpose M DQ full transpose into this. So C transpose into C, you know, it is a 3 by 2 pi. And substituting here we get like this, M DQ transpose into IDQ transpose half times. So IDC can be written as that half into 3 by 2 MDQ and IDQ. So you can write it as a 3 by 4 times of MDQ transpose IDQ. So MDQ is MDMQ, IDQ is IDIQ. So if you multiply these two column matrices with matrix multiplication, we get this equation MDID plus MKQ. Now we are using this equation for the modeling and control. So this is the inverter, and this represents the PV side, and this represents the grid side, and this is the DC link capacitor mediating the PV and grid. So PV current can be written as MPP PMPP by VDC, that is panel operating at maximum power point. So divided by voltage will give us the PV current, and here grid side current is nothing but the DC side current available from DC side, that is PG by VDC. So this current IPV is equal to capacitor current plus this IDC current. So IC is, you know, this IC is CdVC by dt, and IDC we have already done here, that we are substituting somewhere here. Then if you write for this parameter change in DC link voltage with respect to time, then we will get this one. Considering the small disturbance the system, the above parameters can be written like this, where VDC is the DC link voltage, MD, MQ are the modulation indices, and D and Q axis, and ID and IQ are grid side currents, AC side currents in D and Q axis, and IPV is the PV current. Here assume the parameter is X, it may be voltage current or PV current. It is an instant XDC here, like VDC, small VDC. This is the instantaneous parameter, varies with time because the power imbalance, load changes, switching, etc. may change this parameter. XDC is a steady state parameter, operating point about which the converter is linearized. Assume VDC is equal to 600. We assume that VDC must be equal to 600. That parameter we can consider as this capital letter V or M or current ID. And here the cap parameter, that is VDC cap, MD cap, and so on. This parameter is a small signal perturbation given that represents a small deviation of the parameter from its steady state value. Assume small VDC is 602, capital VDC is 600, then this VDC cap must be 2 volt, not more than that. It is a small perturbation or small disturbance given, and we'll check how the system behaves with this small change. Means we are doing control action, means we are just changing the overall value with the small increase or reduce the value with a small quantity. So that is the disturbance signal we are giving. So VDC is equal to IPU by IS. Just we are transforming the given equation into Laplace form, and we are replacing that ID, that is this parameter MD ID plus MQIQ as MIA plus MBIB plus MCIC with considering the disturbance signals. Then considering the bandwidth of the current controller, the voltage controller, transfer function ID and IQ is 1. Then this is the overall DC link voltage block diagram. Here if you observe, this is the DC link voltage reference. Assume it is a 600 volt. Assume it is a 600 volt. And we are assuming VDC as 600 volt, and we are comparing it with the DC link voltage, actual value with reference value. Then we will get some error value, and that error is given to a PE controller, and then it will generate the direct axis value ID star, and it is compared with ID, that is a measured D axis current. Actually this ID and ID star is obtained from the current I. I is IA, IB, IC is converted to ID, IQ, and that ID component is given here, and this is the ID reference. So based on that we have a current controller. This will generate MD, modulation index in the D axis, and here we have a, usually to maintain the power factor constant, the IQ value is maintained at 0. This is IQ star is 0, reference is 0, this is IQ, then we will get an error. So here this is MQ is obtained from this, Actually, ID is nothing but MDID plus MQIQ into 3 by 4. So for that we are doing this math, and after that IDC minus IPV is IC visual. IDC is IPV is the DC side current, IDC is the AC side current. So the difference will give us the capacitor current. So IC by CS, that will give us VDC. Actually, C dVc by dt is equal to I. Based on that, we will obtain this expression. Then we will get the DC link voltage that is given as a feedback to the second. Okay. So this is the overall DC AC voltage control and current control of gridded PV system. So here we have mentioned all these values. GV is the voltage transfer function. That is this ID by EVDC and KP plus KA by S. There is a PA controller. GID is the current control for D axis, and GIQ it's not mentioned here. So this is the current control for Q axis transfer functions. And here ID is obtained from DC link voltage control, and IQ is maintained. IQ star is maintained at 0 to make the power factor, maintain the power factor unity to transfer the power to the grid. So the outer voltage controller generates the current reference ID. The inner current control produces the modulation indexes MD/MQ, which is determined the inverter power and hence the DC link voltage dynamics. Here the main control objective is to maintain DC link voltage constant VDC star by regulating the ID current, that is active component of current, and IQ controls the reactive power, usually set to 0. We are not intended to control the reactive power. If you want to do the power flow control, in that case how much of active and reactive power we need to pump into the grid, or we need to draw the reactive power from the grid. In that case we have to give some IQ star, but as of now we are just generating the PV power and feeding it to the grid. For that case, this is the control strategy.